Eco Forward Consulting. My name is Lizzie Torres, and I'll be presenting with Moana Torres. In this presentation, we will be going over a general description of the Bacote dump site, the closure timeline, the closure plan, the new landfill description and design, and recommendations. The Bacote dump site is located in Canifing in what used to be a quarry in the 1980s. The site area is approximately 17.8 hectares, and it is located in a densely populated area. Some issues that are common in the dump site are smoldering garbage, animal scavenging food, and an intense stench, as well as an unsightly view. Other environmental and health concerns are air pollution, surface and groundwater pollution, a risk of slope instability, and a high density of mosquitoes from ponded water. Eco Forward Consulting prepared projections for the population and for the waste to reach Bacote based on 70% collection out of the total produced waste. In 2021, the population was estimated to be 437,000, and in 2030, 509,000. These projections were based on the population growth rate for the 2013 census, which was found to be 1.7% per year, and from the recorded incoming waste growth rate calculated from the 2011 to 2013 incoming waste to the Bacote dump site, which was found to be 7.5% per year. As a general plan, we recommend the decommission of zones 1 and 2 and recommend using zone 3 for organized dumping.
In this section, we'll talk about the closure timeline. This following figure shows a general timeline of the closure of the dump site as well as the construction of the new landfill.
Moving on, I will explain in detail the phases and subphases in the dump site closure plan. Note that the phases and subphases are not meant to be performed only in a consecutive order, but rather simultaneously to the capacity of the municipality. In a period of 5 years, for this example, from 2021 to 2025, Eco Forward Consulting is recommending Phase A to be performed. So for Phase 1.1 from Phase A, it consists building the treatment ponds and the constructed wetlands. This is illustrated in the image on the right. So zone 3, which is the center, was divided into 4 quadrants, 1, 2, 3, and 4. And the treatment ponds are recommended to be built in quadrant 1. However, this would require prior geotechnical assessments and slope stability tests. And it will require the placement of a compacted clay liner of 1 meter thick. The treatment ponds will consist of first an anaerobic pond, then an aerobic pond, and then constructed wetlands. Phase A, Phase 1.2 from Phase A will consist on suspending dumping in areas A, B, and C, shown in the figure, and on grading zone 3 and building a culvert system for active landfill surface runoff, which will be connected to the treatment ponds. Phase 1.3 of Phase A will consist on decommissioning areas A, B, and C. So this means that the waste will be graded and it will be compacted, and a final cover will be placed. The final cover will consist on a clay liner of 50 centimeters thick and above a soil layer of greater than 50 centimeters. In addition, a culvert system must be built, and this is represented in the figure by the black lines, and its direction is also shown in the picture. The circles represent testing stations to ensure that the water that is the surface runoff from areas A, B, and C, if they're contaminated, then they will need to be treated in the treatment ponds. However, if not, those will go into the turquoise colored culverts, which are for stormwater, and will go to the nearest water body. In this case, presently that will be the ocean, and this is assuming that there's already a sewage system that would connect to the ocean, and if that is not available, then the infrastructure would need to be built. The third part of phase 1.3 is building culverts for surface runoff from roads. As I mentioned earlier, that it's the turquoise colored lines, and those will be connected to the, if deemed within parameters, the surface runoff from areas A, B, and C will also go into the stormwater turquoise colored culverts. In this picture, the leachate collection, the surface runoff from the active landfill is shown in red as well. So from the conservative timeline from 2021 to 2030, so a duration of 9 years, phase B will take place. And it consists on exclusive organized dumping in active gradient of Zone 3. So this means, as mentioned earlier, Zone 3 is going to be divided in 4 gradients. So as the other quadrants are covered with an intermediate cover, which will be 25 centimeters thick, then the quadrant to be selected to be used will be active, and it is recommended to follow a daily cell method for placement of the waste. As shown in the picture, it can require the soil bonds to keep stacking on the side slope, on the external slope. And the daily cover will consist of minimum 5 centimeters of soil or mature compost. For the gas collection, it is recommended in areas A, B, and C to apply vertical extraction wells. These should be placed every 1 acre, which corresponds to 4,047 meters squared. In the case of the active dumping area, which is located in Zone 3, as mentioned earlier, it is recommended to build venting trenches and to place a metallic barrier or some sort of barrier to keep the gravel inside the venting trench clean of waste. Also, it is recommended to utilize the current monitoring wells and build more in different sites of the landfill. So for example, in areas A, B, and C. For the site use, it is recommended for area A to be used for the maintenance and operation offices. It can be used for a parking lot, pending that, like, all of these recommendations are based on the geotechnical assessment and slope stability tests are positive. So area A can be used for a parking lot and for a resource recovery facility, so that scavengers can go there and safely collect any valuable recyclables. And this is to avoid scavengers from being in an active landfill. For area B, it is recommended to be used as the composting station. So EcoForward recommends the Canifing Municipality Council to enforce a waste segregation legislation in which the population that is served by the Bacote dump site can separate their waste into wet, so meaning organics, and dry recyclables. In this way, the amount of waste to be put in the landfill is greatly reduced, and the organics can be used for preparing mature compost, which can be used for a daily cover since soil is not readily available in the vicinity of the area. So it can be used for a daily cover or intermediate cover and even for final cover. Now, Area C is recommended as an alternative resource recovery station.
As of today, ECO4 did not select a site for the new landfill because of the lack of local data on the environment. However, in our report, we did outline a site allocation criteria as a guide for the selection of a proper site once further information is collected. The proposed landfill is built using the trench method, taking into account the level of the water table. Careful grading of the site before putting in place the barrier system will be required. The base of the site should have a slope of at least 2% to 5%. If the slope is greater than 2%, the slope stability of the design will need to be evaluated and the design adjusted as needed to prevent further slope failure. The estimated footprint of the site is 95 hectares, excluding the area of the leachate treatment facility. The possible maximum height of the landfill is 30 meters. To minimize the risk of landfill slides and to prevent erosion, the slope cannot exceed 25%. We at ECO4 Consulting propose a baseliner composed of compact clay soil with a depth of 30 centimeters. In the case that clay soil is not available and if the subsurface layer of the selected site already has low permeability, it is possible to use the soil available on site by loosening the upper 30 centimeters and then compacting it with heavy equipment. The surface of the liner should be sloped at least 2%. Above the baseliner, a non-woven geotextile should be placed to maintain the drainage system on club, but it can also be omitted if it's not possible to get one. Above the geotextile or baseliner, a drainage layer made of gravel with a depth of 80 centimeters must be added. For the waste layer, a cellular structure is proposed. A cellular structure has cells which get full after 1 to 3 months, and within the cells, it has daily cells, which consist of the daily input of waste. The placement of the first layer of waste above the protective layer requires more care in order to avoid damaging the leachate collection system and the baseliner due to excessive load. Special attention must be given to the following points. The unloading of the following waste should be carried out in small working areas in the working phases. The working phase should be only as large as necessary to allow adequate truck movement and unloading space, as well as efficient operation of the landfill equipment. The figure at the top shows a plain view of the landfill with the location of the working phases. We propose a width of 14 meters. The size of the working phase has an impact on the amount of daily cover required, the leachate generation rate, and the amount of scavenging by humans and animals. Therefore, it is important to keep the size of the working area small. The figure at the bottom shows the upfill method used for the cell method. The layer, except the first layer, requires compaction. To compact the daily cells, 30 to 50 centimeters of waste can be compacted at a time with a heavy equipment driving over it 3 to 5 times. After compaction, these daily cells must be covered by a thin daily cover which must be bigger or equal to 5 centimeters thick. After the daily cells have reached a height of 2 to 5 meters, the cell is separated from another cell by a 15 centimeters soil cover. To access the cells, permanent road must be assigned in a single lane road or recommended to ensure a fast flow of the truck and avoid accident. A sawtooth configuration is recommended for the leachate systems. Each set of 2 slopes and low points make a working face as seen in this figure. A heavy-duty thick PVC pipe with holes on the top must be placed within the gravel layer at the lowest point of the sawtooth configuration and sides according to the peak flow. The pipe collection system must have a slope bigger than 2% to prevent accumulation of liquid and provide proper drainage. It is recommended that the piping be secured with supports to prevent excessive movement due to change in temperature. Rigid connections must be designed with appropriate supports to prevent failure. A non-woven geotextile should be placed above the gravel if possible. Otherwise, a 50 centimeters protective layer made of shredded waste, compost, or smaller grain waste can be placed above the gravel to reduce blocking of the drainage system. EcoForward Consulting is proposing a multi-stage treatment in different leachate ponds. It consists of initial treatment in the anaerobic pond and aerobic treatment, followed by a constructed wetland from which the treated leachate is finally discharged into a nearby large water body. A sewage infrastructure might need to be constructed to carry the treated water if there is no prior sewage system in the region. Waste stabilization pond and construction wetlands are effective methods for treating wastewater, and there are low energy consumption ecosystems that use natural processes. Even though this method is inexpensive, its effectiveness is limited. It is important that the effectiveness of the treatment is monitored with respect to pollutant removal, using some indicator substances such as COD and ammonia. The altitude of a leachate treatment pond should be arranged so that it's driven by gravity, so we can avoid using a pump. EcoForward Consulting proposed the use of passive gas collection systems connected to the leachate system. They must be well labeled with bright colors and reflective materials to avoid trucks and carts from trampling them. The collection gas can be pumped into a nearby facility that can utilize its energy pump. However, if there are no such facilities available in the Gambia, a framework of clean development mechanism can be carried out with foreign experts. This framework will work into investigating a system that captures and uses the gas as fuel to power the landfill facility. As a last resort, it is possible to flare the landfill gas, but it is not recommended. If there is no funding for the landfill gas to an energy facility, then the Bukyoko method is recommended. Finally, we will discuss some future steps that should be taken to continue this project. Firstly, we recommend that an in-depth economical analysis is undertaken to have a better estimation of the cost of the project. Information of the cost of the construction, labor work, importation of foreign materials, and others will be needed to estimate the needed funding. Also, groundwater prevention methods are necessary for the safety of the nearby residents and ecosystem. Monitoring the groundwater and remediation techniques should be considered to prevent the dispersion of pollutants to large bodies of water to reduce the risk of pollution to nearby residences. Finally, further field testing and investigation are needed. Collection of recent data of the local topography and socio-economic situation and weather patterns are recommended for more accurate design consideration. Finally, we are thankful that we were able to work in such an interesting and challenging project. We learned many valuable information of the processes and design behind the construction and management of a landfill. We recognize that further research is needed for an in-depth closure plan in the design of a new landfill. We are excited to see the future of this project, and we hope that the people of Kanifing have a healthier and safer environment soon. We hope that this project is just a start and that other countries can get inspired to initiate the closure of their dump site at a faster rate. Here are a list of our references that we used in our presentation. Thank you for listening. Is there any question?
All right, thank you, EcoForward Consulting. Appreciate the nice presentation. I thought you guys did a really good job of overlaying some of your sketches and ideas on the existing Bacote dump site. I thought you had some good information on some of the operational approaches to filling waste in a landfill, both at Bacote and then at the future landfill site. So those are some of the challenges that they have faced previously, is, you know, how do you fill the waste properly, and the use of daily cover. So appreciate all of that. One of the questions that I had was, how do you determine that the current Bacote dump site could handle 9+ years of additional filling, and that you could wait until 2035 for the new sanitary landfill?
I can take that question. So the reasoning behind like preparing the zone 3 to keep being filled with waste was because we know that these processes of like getting budget and actually building the new landfill, it's going to take some time, and there's always like things that can push back the schedule. So we just had a conservative timeline. And also we thought that 9 years would be plausible because we're also assuming that the Canifin Municipality Council would take into account our recommendation on enforcing a waste segregation system. So this would also reduce the amount of waste produced.
Just thank you very much for the presentation. I think that was excellent, and then you guys have did brilliant work in terms of making some researches to come up with those sketches. I think your landfill sketch, new landfill sketch, one of the first that I saw during the presentation, because I didn't see any sketch for the new landfill. Now, regarding, you made mention of zone 1. Sorry, zone, hold on a minute. Yes, zone 3. It said you're gonna excavate waste from zone 1 and 2, and then transfer it to zone 3. Zone 3 is almost full, meaning the waste that you are going to bring from 1 and 2 and add it to zone 3 is going to be like too high. It's going to be big heap for that matter. And then even to have access to it will be a very big challenge. I don't know what are the criteria that you looked at in order to be able to select zone 3, you know, to manage the Bacote dump site for almost 9 years.
So we actually had a change in plans because we like realized that moving waste from zone 1 and zone 2 into zone 3, like that was our initial plan, that wouldn't be possible. Like it could be possible, but it would be a nuisance to the community from the smell and also very expensive. So then that's why we changed the plan to decommissioning zone 1 and 2, and so like not using them anymore, and then using zone 3 for the remaining years of the dump site before the new landfill is ready for use.
All right, because that's right, because as I said, zone 3 is almost full to capacity. It might require some excavation if the patrol we are to manage up till 9 years. I think that will not even, as Chris just rightly mentioned, to manage zone 3 for 9 years is almost going to be very difficult. Thank you very much.
Mm-hmm.
Yeah, I echo some of the earlier comments. I think the site layout is very well thought out. I like some of the features with perimeter venting, trenches and keep surface water out, etc. Question I have is if you could just expand a little bit on what your plans are for waste diversion. I saw a mention of a future resource recovery potential in one of the zones at Bacote. You also mentioned potentially source separation at the homes through an education campaign. But could you expand a little bit on kind of the plan for waste diversion rather than just all landfilling?
Yeah, I can take that question. So the plan is, so first, the Canife municipality would need to enforce the segregation between wet and dry, so organics and inorganics. And then after decommissioning of zones 1 and 2, or like area A and B, area A, B, and C, or it could be even done before the decommissioning is complete. But the plan for the wet waste, so the organics, is to prepare compost and prepare mature compost. So then that mature compost can be used as daily cover and to fulfill that need for soil. And also a mature compost works as a medium for methane oxidation to take place with methanotrophs, which are bacteria that live in aerobic environments. So that would be a small way of accounting for treating the methane that's being expelled from the landfill. And then for the non-organics, we were referring to the resource recovery station, which would be a place where all the dry waste would be placed, and where the scavengers or the waste sorters that are currently working in the landfill could go and sort for any waste that they find useful, or like that they have value, and that they can find a value for it. And then the rest of the waste that is not useful for them, then that can be placed in the quadrant that has been selected for use. And in that way, we are keeping the waste sorters away from the active landfill, from the active zone 3. The purpose is just to keep them away from the zone 3, because it's dangerous.
Yes, thank you very much.
Thank you.
And I'll ask one question. Just echoing the same thing first with the whole panel. Thank you all for such an outstanding work. It took a lot of work and lots of effort. So we appreciate all the energy and time you guys have put into it. It's definitely not a waste. It's lots of great ideas from your team and from all the other competitors. My question for your team is similar to other questions I've asked. As you know, Backwater is a dump site. It doesn't have a liner at the bottom. You've talked about dealing with the water contamination. What would you guys suggest as a way to deal with that as you decommission the other zones outside and focus on zone 3? Even though you're putting daily cover and you're putting a final cap whenever you get to the top, what are your thoughts on the groundwater contamination possibility and how to mitigate that as you go?
Yes, so I can answer that question. So the main like our main strategy was to first avoid any new water from going in. Well, that's not completely possible, but that's why we're proposing the grading. So whatever it's contaminated, if like ideally the areas that are decommissioned, area A, B, and C, are graded well and the coverage well, so that it doesn't produce any surface runoff that needs treatment and can just go directly to stormwater management, the sewer. However, for zone 3, since it's active landfill and we're proposing what you said of putting the daily covers and intermediate covers, then that will need treatment in the treatment ponds, aerobic, anaerobic, and constructed wetlands. And then for the groundwater contamination, we assume that there's probably already contamination happening. So a solution to that would be pumping contaminated water at the bottom. So like to the eastern side in the area where the pond was, and then directing that water to the treatment ponds. However, the treatment ponds, I don't think they're large enough to treat that amount of water. Also, another thing that can be done is at the upper side, so in the western side, kind of like a, not a wall, but some sort of structure to stop water from, groundwater from flowing to the eastern side towards where the pond used to be. So to prevent any new groundwater from flowing through the dump site and being redirected to the sides. And then the water at the bottom on the eastern side can be pumped and treated and then re-infiltrated. However, these would be very expensive. So it's something that we are aware that should be done, and it'd be great if funding could be received for that, and also to let people know that drinking the groundwater isn't safe, because we know that we read that there were a lot of people were having a lot of stomach issues and other diseases from using this water, possibly. So yeah, that's what we think could be done.
And just to add to that, it's really important to treat the water as it's close to a creek that continues and that could meet and mix with the groundwater. And so we did mention, we had a mentor, and I did mention that we should have the barrier as well as pumping, and a lot more research is needed to concentrate all this water collection and to avoid any contact with the general public and even bigger water bodies, because then you could spread around the whole country and that could be even more detrimental.
All right, thank you so much. That concludes our Q&A session and concludes the competition.